Okay, this table shows the true value of some quantity against the measured value obtained from some practical work. So if you're accurate, the true value will equal the measured value. Sometimes your data can vary like this. Your actual measurements can be shifted either up or down in a systematic way like this. Okay, or sometimes it can vary like this, where they've been multiplied by some factor which is shifting it again in a systematic way. Okay, this is called a systematic error. Systematic error causes your readings to differ from the true value by a consistent amount or factor each time the measurement is taken. Okay, an example of a systematic error is zero error. That's when you forget to press the zero or tear button before you put the weight that you're trying to measure. So if I take this weight off, it would actually give a non-zero reading, either negative or positive. So the only way to deal with this is either take the weight off and press the zero button and redo the experiment, or you can note down how much the mass is off by and subtract that or add that value to all your subsequent readings. Okay, this practical here is used to find the resistivity of a wire. You're changing the length of the wire and you're noting down the resistance. The problem with this practical is if you make the wire too short, then the resistance would be low and the current will be large, and the current has a heating effect which is going to cause the temperature of the wire to heat up, and that's going to cause the resistivity of the wire to actually change during the experiment. So you're not actually keeping your control variables constant, which should be the temperature. So one way to keep it constant is use a variable resistor to keep the current at a constant low value, keep it fixed as you change the length. Another thing is not to leave the circuit on when you're not taking measurements. This should also minimize the temperature change of the wire. Okay, in this practical, you're investigating if pressure is inversely proportional to volume. So you're compressing the gas and you're checking how the pressure changes. But however, this is for a constant temperature and number of particles. Temperature won't be constant if you compress the syringe too quickly. That's actually going to cause the gas to heat up. So you need to make sure you take care to do this experiment as compress it slowly and let it reach a constant temperature. And secondly, you need to make sure the seal is tight, otherwise the number of particles will decrease as you compress it. Okay, parallax error occurs when the reading position is at an angle which is not perpendicular to the object. So for example, you're not reading at eye level. So this is a systematic error when you're constantly reading it from either too high or too low. It would be a random error if you're constantly reading it from above and below, because those effects cancel out. But if you're always reading it from above, then all your readings here in this case will be too small. Okay, in this practical, you're timing how long it takes for the ball to fall a certain height and using the data to find the acceleration due to gravity. However, if the height that you're using is very large, then air resistance is going to start playing an impact on this role and it's going to give you an inaccurate result. So you need to consider the resistive force and choose a suitable range. Okay, in this practical, you're adding weights onto a spring and recording the extension and using that to find the spring constant. Now, if you use masses which are too large, then you're going to go beyond the limit of proportionality and possibly even the elastic limit, which is going to give you data which is not going to give you valid results. Okay, another common error is miscounting. So if I'm trying to find the width of a fringe here, and I'm going to take a number of readings across this set here, an incorrect way would be count like this. So you're counting 1, 2, 3, 4, and you're counting the number of dark fringes, and you're going to take that total distance and divide it by 6. That's incorrect, because the truth is there are actually 5 fringes in that gap. So really you need to take the length there and divide it by 5 to get the width of each fringe. Okay, this is a simple pendulum. You're trying to count how many oscillations take place in a certain amount of time. So you start the timer when it goes to the fiduciary marker, and some people miscount this because what they do is they time how long it takes for half a cycle. This is only half a cycle. A whole cycle would actually be to go all the way to the right hand side and then to the left and then back to that same point going in the same direction. Okay, systematic error occurs when there's something wrong with the technique or the instrument that you're using. So you can't just remove systematic error by repeating the experiment and take an average. That will minimize random error, but it won't get rid of systematic error. It'll still be there. So the only way to get rid of systematic error is to first repeat using a different technique, recalibrating equipment, or just using a whole different set of equipment and then comparing your results.